Just a sec. Just a sec. Okay, I reposted it on X. Now I'll just do Blue Sky and I'm ready. So just a second. Just a sec. And I'm done. So you can start, Steve, if you like.
Alrighty, here we go for the editor. Hello, everybody. Welcome to another exciting episode of JavaScript Jabber. I am Steve Edwards, the host with the face for radio and the voice for being a mime, but I'm your host today, whether you like it or not. Anyway, with me today, I have on our panel Mr. Dan Shapir. How you doing, Dan?
As well as can be expected, given that I live in Tel Aviv.
Yes, I would say it's rather explosive times there, isn't it?
Yeah,
Being in
well,
Tel Aviv.
if you want to joke about it, yes, I can.
Is it so? Yeah, if
Let's
you've
put it
been
this way: there's a greater than zero possibility that during the recording today, I'll need to jump off and run to the bomb shelter.
bomb shelter, yes. Yes, if you've been watching the news, you should know what's going on in Tel Aviv, and we'll leave it at that. With us, we have our very special guest, Mr. Dmitry Metropolis. How you doing, Dmitry?
Great. Happy to be here. Thank you.
And yes, we were asking him ahead of time. That is Metropolis, as in the same city where Superman lives. So
it's an old Greek name, so it's probably
right.
in the old days was pronounced a little different. Ancient Greek was a tonal language actually, so it had pitches like Chinese.
Yes, right.
Very different from how it sounds today.
Yeah, that's true. I've spent some time in China, and I have friends that have lived there for a long time and speak Chinese, and the tones make a huge difference in what you say. You can say one word with two different tones, and they mean two different things. And if you get lazy, you can say something that you really didn't want to say.
It literally means city, doesn't it?
Yeah.
And by the way, which
place of
city
people,
do you?
I think.
Oh, okay. And
Yeah,
by the
yeah.
way, which city do you actually live in?
I live in here in Michigan. I live like a little bit north of Detroit.
Cool.
The Mitten State. Yeah.
The
People
Mitten
make fun
State.
of us because you can say
Right.
where you're from by holding up your hand.
Right.
But hey, whatever.
Are you one of those UP people, or are you down on the
No, I'm not they're called Yoopers. I'll have
Yoopers,
you know.
right?
Yeah, I'm
Oh,
not a
yes.
Yooper. But it's beautiful up there, so I won't hate on them.
There's I still have this really old humor song on my computer from a group called The Yoopers, and it's about the second week of deer camp. So they were like a little comedy group back in the day.
Sounds about right.
It's a very old song. It's the second week of deer camp, and all the guys are here. Anyway, so moving on to our topic du jour, we're going to talk about Dimitri's. Oh,
I would like to introduce a topic if you don't mind,
go for
because
it.
I was first of all I have to mention that it was when it was announced, it was obviously my pick on the very next podcast, and I basically called shotgun on it, so nobody else could pick it, because for me it's a totally insane, wacky, and out of this world project. It's simultaneously amazing and I think also educational. The fact that it was actually created and the amount of effort that you put into it, based on the videos that you released about it, is more or less insane. And we will obviously learn more about it. So, without further ado, what did you do?
I think I had a thought, and the thought I could never let the thought go. I think that's ultimately the answer to the question of what I did. And the thought was, yeah, but there's no way you could run Doom in TypeScript's type system. That was the thought. I think that I have opinions that inform that thought. And one of the core ones is my feelings about what it means for a system to be Turing complete. So a couple of years ago, someone posted an issue. It's still open on the TypeScript repo saying, "Hey, I was just playing around and I noticed I think the type system is Turing complete." And it got a lot of press, and it was very, we all had a laugh. Everybody, TypeScript nerds, had a laugh about it. But since that time, I think people would say, I'd hear here and there someone say, "Oh well, but if it's Turing complete, then of course it could, XYZ thing." And I just think that's baloney. It's totally, I just fundamentally cannot get on board with that kind of thinking, because Turing completeness, well, we could,
Let's
you direct me
define
down that
Turing
path.
complete. Yeah, let's
Okay,
define
sure.
Turing complete.
So there's this guy, Alan Turing, and he made quite a lot of contributions to society, but one of them was he described a system that we now call a Turing machine. And Turing machines can be used to represent arbitrary calculations and perform arbitrary CPU work. And Turing machines are well known for being extraordinarily simple. Actually, you can do it in binary. You can do it with like a ticker tape. You can think of this little bug kind of dancing through a ticker tape, looking at the 1 0 or 1 bit in front of it and making a decision about where to go and what to do next. And so,
Basically, it's if I remember correctly, it's a theoretical machine
yes,
that is the simplest mechanism that can perform any computation.
right. So if you can show that a system is Turing complete, there's a chain of mathematical proofs that demonstrate that you could build your way up to creating an extraordinarily complex system, like in fact, any computer could be built from the bones of a Turing complete machine theoretically. And the theoretically part is where I totally fall off from the bandwagon, because to me, it's not interesting. So if I told you, "Hey, Dan, I have this machine in my basement, and it can compute, 1 + 1, except that it will take 100 million billion years, and all of the atoms in the observable universe. Isn't it cool?" Now tell me, Dan,
Well,
how cool do you
that's
think
more
that
or less
is?
how we're supposed to prove string theory. I believe they need to build
Right.
um, a Large Hadron Collider the size of the universe or something along these lines in order to prove it.
Right. So, like, I just don't find that super interesting. And so, what happened was, I have a YouTube channel that I participate in called Michigan TypeScript, and I help out with making videos there. And I got the thought one day, would be a cool project is to show what the blocker is, why, to demonstrate the thing that I just laid out, which is that being Turing complete is not enough. You need a lot more, and so in order to do anything of any like real significance. And I thought this would take 1 or 2 weeks maybe of like putzing around with the type system. I have to mention, like, I had done a video series on advanced TypeScript type stuff. So there's these things called the type challenges made by Anthony Fu. Really great stuff, but they're very hard. And like the last one is making a JSON parser purely in TypeScript's type system. So some people are not aware that you can do arbitrary kind of computations. It's called type level programming these days. And there is a lot that you can accomplish with very small building blocks, almost like what a Turing machine gives you. And so I just thought I would work on
If
finding
I
the
can
reason.
stop you for a second,
Please,
because
yeah.
I'm thinking that we are potentially losing some of our listeners on
Okay.
the distinction between running things in TypeScript
Right.
versus running things in a TypeScript type system, because it seems like it should be the same thing,
Right.
but it totally isn't. So
So
maybe you can make this distinction clearer before we proceed.
I love it. Thank you for stopping me. Yeah, it's a very important distinction. So TypeScript's whole point is to add types to JavaScript. So JavaScript is an existing language, but it doesn't have a type system, in the sense that you can't say, here's a variable, and this variable is a number, and it can only be a number. So if you try to assign a string to it, we're going to have an error. That's something that TypeScript gives you, but JavaScript is lacking. And that's the whole point of TypeScript in kind of the most essential sense. Over the years, as TypeScript has evolved, there are more and more things that TypeScript has enabled you to do with the type system. So originally, it was very simple types, like I just said, like number and string. But eventually, they started being able to do things with what we call literal types. So what if instead of saying I have this variable and it's a number, you can only assign numbers to it. If I say I have this variable, you can only assign these specific numbers to it. You can only assign 1, 2, 3, and 4 to this variable. And if you try to assign 5, even though it's a number, we're going to give you a type error. So there are literal types. And you can do this with strings too. So you can say, I have this variable. The only types that are allowed to assign to this variable are red, green, and blue. These, RED, GREEN, BLUE. Those are the available string options that you can assign to this type. Well, there's another thing that they added that goes even further, which is that,
And again, I'll stop you for a second
please,
just to
yeah,
clarify why this might be useful. Because, and I think your example with colors is excellent. Because, for example, if I'm implementing a type or a variable that's supposed to contain a color that, for example, we use in CSS,
mhm,
and I don't want to allow any arbitrary string to be assigned to it, I want the static type checking to validate that at runtime, well, actually at build time, I'm validating that I can only assign specific string values to it. And if I try to assign a general string to it, I will get a development time or a build time type error.
exactly. Yeah. What if you you just have a typo? TypeScript is really amazing because it can keep these kinds of errors, this whole class of errors out of your
Yeah,
program.
I write rad instead of red or something along these
Right.
lines.
Exactly. Yeah. Perfect. So the second thing that they added is something called generics. Generics exists in lots of languages, but generics is a way to operate on types. So it's kind of like a function. You say, I'm going to take as a parameter some other function, like we were saying red, green, and blue. Okay, so I'm going to take some other type and you can add to it or you can change it or you can inspect it and see what it does and do something different. So you can say, oh, if it's red, I'm going to return the number 1. If it's green, I'm going to return 5. And if it's blue, I'm going to return 1000. You can do stuff like that.
Is that
And
is it an oversimplification to say it's almost like a class override in object-oriented programming, where you can take something and extend it?
Yeah, but it's done at build time or dev time
mhm.
rather than at runtime. You're specifying either the arguments to the type are themselves types.
So it's kind of like its own programming language tucked away inside of JavaScript. It's like you have JavaScript and then you have this other language on top that allows you to kind of speak in these other terms. And it's often in reference to what the JavaScript is doing. I mean, that's the intention.
I'd like
But
to
you can
give
actually
another
separate.
example. I'd like to
Please.
try to give another example that might clarify why something like this might be useful. Let's say I'm implementing a calculator, a hand calculator, and I want
Mhm.
to do it in a type form, and I want to represent an expression. For example, I want to represent the addition operator. So the addition operator has something on the left, the addition operator, and then something on the right. And I can say that an expression is a generic type that has a number on the left and an expression on the right.
Mhm.
So it's so it's am I kind of getting the point across, Steve?
Yeah, I think so. I mean, being the visual person that I am, probably easier to see some code examples, but yeah, I think I get where you're
Sure.
going.
Yeah. So you can provide you can create functions that are kind of within the type system only. And you can create types that that are just artifacts of the type system that don't exist at runtime. So JavaScript is really weird because we kind of attached a type system to it later. I mean, this also kind of happened in Python, but it's a part of Python. Whereas in JavaScript, there is no part of JavaScript that includes a type system. It's like purely TypeScript and the TypeScript team. There's no spec for it either, right? It's just something that they kind of developed and designed, and they have documentation, I guess, but the JavaScript language itself is standardized and has a specification that's completely abstracted from the engines themselves, like V8, that run the JavaScript code.
That's the ECMAS spec, right?
Yeah,
Is
Yeah,
that right?
that's the
exactly. Yeah,
Yeah.
ECMAScript. That's the name of the
European
standard.
Computer Manufacturers Association. Yeah, that
By the
little thing.
way, an anecdote. That's the origin of the acronym, but ECMA is no longer an acronym. They've turned it into the name.
Oh,
So
Right.
really?
yes, so it's
Oh,
literally it's trademarked as ECMA, the word ECMA.
that's interesting. I had no idea. Um, well, I'll put that in my bag of
Useless
bar
knowledge.
trivia. Yeah, useless knowledge. Exactly. It's cool to. It's kind of fun to know this kind of stuff, though. So what happens is similar to how we were talking about a Turing machine. As you start to have bigger and bigger building blocks that you construct, you can start to do harder and harder things. And my thesis was on this project, that may be true, but there's going to come a point when you hit some kind of immovable object. There's going to be some unstoppable blocking point where you can't continue pushing because you hit some memory constraint or you hit some CPU time constraint or you hit some issue that is just not solvable with the tools that we have today. Like maybe someday someone could do it, but I was sure that it would never be possible in today's TypeScript to be able to do something like run Doom. And we can get into like what does it even really mean to say that you ran Doom, and I can
Mm.
explain that. But that was basically the idea of the project.
But again, moving slightly back to the
Okay,
type
sure.
system itself, in order to say that a type system might be Turing complete, and by the way, TypeScript is not the only one. I encountered a similar situation with generics in C++ back in the day.
Yeah, C++ templates are also on the
Exactly.
list.
Um, so basically, once you have generics and the generics are flexible enough, you become Turing complete because you get effectively loops and conditionals, which is basically what you really need in order to kind of be Turing complete, right?
Interesting side note on that. I learned that actually the definition of a Turing machine does not include the ability to loop. It it's so like C has a formatting syntax, right? There's like the C printf formatting.
Yeah, the
Uh,
preprocessor.
it's also considered Turing complete, but you need to invoke it over and over again in a loop outside.
Oh,
So
because you can write infinitely long
right.
programs, right?
So it's not included in the, which actually to me really adds fuel to my fire because like I really have the position, and I still do after completing this project, that calling something Turing machine complete is not really that interesting. I don't find it that interesting. I think actually, I'll tell you a funny thing about Doom. Actually, independent of my project, I learned when I released this that the Doom game, not like the engine, but like inside the game with your character and the gun and like things that you can do in the game, is known to be Turing complete because I was listening to watching people argue about this in comments, and one person was saying, well, actually the measure should be Doom complete. If the system can run Doom, then that's like the bar of what is mathematically interesting. And someone said, well, you could make a computer that only can run Doom and can't do anything else, and then like that's not very interesting. You made an ASIC basically for just Doom. And then they came back, the first person came back to say, oh, you must not be aware that the Doom game itself is Turing complete. And so then you have the full circle completing the loop that actually, and so this is my champion thing I'd like to champion to the world, is that actually Doom complete is the more interesting mathematical
Mm.
proof.
By the way, I'm reminded that somebody implemented a CPU inside Minecraft.
Yes, yeah, exactly. Yeah. So it's a similar sort of project to something like that. Yeah.
So going back to what we were saying, in the context of the quote unquote Doom complete, the type system itself provides the building blocks for implementing conditionals and loops, right? I mean,
Yes.
conditionals would basically be, let's say, a generic type that accepts two types and then in a condition, and
Yep.
based on evaluates that condition at build time, and basically would return either the first type or the second type based on the condition.
Right. Exactly. Yeah. That's basically the kind of core building blocks that you have. You have, and then from there. So what's funny is there's no loops in the type system, but there is recursion. So
Well,
anytime
recursion
you
is
want
a
to
loop.
do right, right. So, but I'm saying there's no construct like in JavaScript. You can make a
Yeah,
for
I know
loop.
what you
You can
mean.
make a while loop. but there's no construct of anything like that. But you can achieve it by making uh, conditionals that have recursion inside of them. They have to have conditionals because, of course, if you don't have a condition, then it could loop forever. But anyway, this is the construct that you end up using. And so actually all of the machine state and all of the looping and all of that stuff happens with recursion purely.
Well, when I first saw it, I laughed because again, I encountered similar, not nothing to this extent, but similar, uh, uh, let's call it similar kind of projects in concept, not in scope,
Hmm.
back in the template C++ template days. And basically, it's because if you think about it, a type system with generics is effectively a flavor of Lisp.
Yeah, I tell people that it's very much like a Lispy sort of thing where you also don't have statements. All you have is expressions. So you have a sense in which you can create statements by having an expression that is returned from something else. And there are some workarounds that I came up with, but didn't end up actually needing to use to kind of fake statements using generic parameters. But yeah, in the end, it's a very straightforward system. If you just think of it like Lisp, it kind of maps to that fairly directly.
So basically, when you write a program, let's put Doom aside for a minute. Let's say I'm writing a much simpler quote unquote program in the TypeScript type system.
Right.
I run the program by executing TSC, right?
Right. Yeah. So you run the type checker. So there, the thing that we talked about in the beginning that keeps you from mistyping red or green or blue. That system is the thing that is actually running your, program, if you want to think of it that way. And the program is a type. So actually all of Doom had to be converted in a sense into a single individual TypeScript type.
So that begs the question again, before delving into Doom itself,
Yep.
how do you input or output anything?
So ASCII art is the way that you output. So you basically, because I said that you have strings, I found a way to display a kind of two-dimensional string. So you have new lines, and it's actually new lines are collapsed by the editor. But essentially, what happens is there's a type, and you hover your mouse over it, and what appears in the hover that's supposed to be the place where it is the place where it tells you what the type of that variable is. What appears is a frame of Doom. That's the end kind of result of the whole thing. As for inputs, the inputs are like pre-encoded, but you can send them in as parameters. So it's kind of similar to any kind of other programming where you would have there's no keyboard inputs and there's no time dimension. So if you have keyboard inputs, you would use like a list of keyboard commands, very similar to how like a tool assisted speedrunner works. So you would just say on this frame, do this, on that frame, do that. And it would take those on a frame by frame basis and execute those keystrokes. So I
So,
actually also did a version of Pong that is a simplified version of the whole system just to demonstrate how that works. And it's in the
so
code base.
basically, you've got, let's say, the output is the display and the current state, and the input for the next frame would be the current state and whatever keys were pressed.
Yes,
And I air quoted keys.
exactly. Yeah, you got it. It's a functional it's just like pure functional recursion state machine. Yeah. Simple as
Hello,
that.
church. You know what I'm referring to with church.
No.
Well, he lambda calculus. He's
Oh,
the
the
father
person.
of
Okay,
yeah,
yeah,
the
yeah,
church,
yeah.
the person. He's the
Yeah,
father
yeah.
of lambda
Well, what is it?
calculus.
It's what's the theorem? Is it the church something hypothesis? I don't know.
Oh, I forget. I need to check on Wikipedia or something.
I'm not. So I have to say, what like one fun part of this project for me is I don't have any. Um, I think ignorance played a very key role in the completion of this project because I didn't know. I mean, I didn't know anything about any of this stuff. I had never written C code before. Doom is written in C. I had never touched huge portions of the things that I learned in this project. I've had some really fantastic jobs over my career, and I've really enjoyed the things that I've learned. But I learned more and on this one project than I did in the prior 10 years of working professionally quite hard. I might add, like you can get out a lot out of a personal project like this that, my job was to figure out how it all works. And there's no stone that I could leave unturned.
So basically, you're saying you had this crazy idea, you thought that it must be impossible,
Yep.
and you essentially set out to prove that it's impossible.
Yes.
And that every time you ran into what appeared to be a brick wall and kind of thought about saying, hey, I proved it was impossible, you said you had the thought of actually, I can overcome this challenge, right?
Yeah,
That's more or less the
it's
process.
exactly. Yeah, I mean, it's funny. There was someone on Reddit when the video was posted announcing the project, and we were kind of talking about burnout, and they said, "Yeah, I mean, it's kind of weird that I was a little burned out before starting this project, and this was a kind of way to rekindle the love of the software craft and programming." And they said it's kind of weird that you solved your burnout by working 18 hours a day because I worked very hard. But my answer to that is I think burnout happens when you work on something and you don't get what you perceive to be a result. Actually, I've known people who get burned out that are not working hard, and that itself can be like something that burns you out. It's when you don't perceive there to be something coming out of your efforts. And this project was the absolute opposite of anything like that. It constantly happened to me that I would think, no way is there any chance that I'm possibly going to be able to solve that problem. And then some hours would pass and I'd go, well, you know what? If I could solve these other three things that are kind of sub problems of that larger problem, then I probably could hack my way through it. But I'm not going to be able to solve those three things. And so I would go down the path of trying each one of those things. And for each one of those things, in many cases, I'd go, there's no way. Right over, it would happen all over again. I'd say, there's no way. And then, but that experience of thinking there's no way I could do it, there's no way I could make this happen, and then making it happen a day or a week later, over and over again on thousands of little problems, that was very invigorating for me. And it was very motivating for me.
And you kind of hinted at that, but how long did this take you?
I have such a hard time answering this question. So, like, in total, from the moment I started trying to the moment I announced the video was a year and a half. Over a decent portion of that time, I was unemployed, like let's say 3 months or 4 months. And I worked very, very hard on it. Like I was absolutely at my desk typing for at least 18 hours a day. Like, I mean, there were some 24-hour stretches where I literally did not stand up from my desk for one whole day-night cycle.
If I may ask something
Sure,
personal, and feel free to not
please.
answer, are you single?
Yes, I'm not single. I have a wife and two kids, two young kids. I
They must
think
be very understanding.
yeah, I think like actually some people ask to follow your lead on the personal note there. Some people ask like, well, like why do a thing like this? Personally, for me, one of the reasons is I worked so hard on this project. I really, really pushed myself as hard as I have ever pushed myself on anything for so long. And I did actually after that 3 months, I did do some contracting, and I eventually got a job working full time, and I fit this in. And I have SquiggleConf as well. I started a conference during the same time, so there's a lot
With
going on
Josh, with
with
Josh
Josh.
Goldberg.
Yeah, Josh Goldberg.
Yeah,
Yes,
who
exactly.
was a guest on this podcast as well. And by the way, I recently just met him at the conference in Romania. So yeah,
Oh,
he's a
awesome.
great guy.
Oh yeah, right, yeah. So
And I have a siren, and I will have to drop off. I will rejoin you hopefully in about 15 minutes. I
no
apologize
problem.
for that, and to our listeners.
So what happened is you know, I put this project together, and it took a year of so much hard work. And I always say, like, imagine so my wife is not technical, she's not an engineer. And I just kept telling her, this is such a big deal. This would be really cool if someone could do it. And she supported me throughout that entire process. And there was never a moment when she doubted me or said, are you sure this is really worth all this effort? She would ask how it's going a lot, and I could never really give a good answer because I thought it was always a day away from being over. But for me, it did wonders for my marriage in a lot of ways. Like imagine the trust that's built over a project like that. And, you come out the other side successful and find out that, you look back and see that your partner was supporting you and picking up slack the whole way while you were, in your dungeon, coding for 24 hours straight without being, there were many nights where she would set a cold plate on the table next to me because I missed dinner, and then she would come back. And these moments are temporary. I spent quite a lot of time with the kids and the family, but for me it's very hot and cold, and when it's hot it's burning hot, and when it's cold it's ice cold. There were also days where I didn't touch it, but it's hard to answer how long I spent because I remember times where I had to drive an hour from place to place to get something or do something, and I don't even remember the drive because the whole time I was just thinking about like some algorithmic challenge or some process that I had to work through with this problem. And it's it's tough to put it into numbers. Yeah, that's the answer.
So it sounds like you were pretty bipolar about it, huh? I mean, very hot
I don't know,
and very cold.
yeah, that I suppose. Yeah, well, I mean, like, I don't know. I don't think I have a diagnosis or something like that, but it's just I don't find it difficult to focus for long periods. I've always been that way. But I also don't find it hard to, it just depends on what mode I'm in. But I find it very easy to switch into a mode where it's like hyper focus. And I find it also easy to switch into a mode where I'm doing 10 different things at once and like none of them really get the attention, primary attention. Yeah. That'd be the way I would put it. Yeah.
So, so other than, wanting to achieve fame so that you could be on this podcast, I think of the quote, Edmund Hillary, why did you climb Mount Everest? Because it was there, so does this, I'm trying to think how to ask the question. So now that you've done this, is this, give you skills you think that serve you, in job hunt or job? Is it just more for personal satisfaction? Like, hey, I did something that I thought was impossible.
Right.
Or, what's the worldwide fame that this
I'll
is
tell you
brought to
I'll tell you the truth. The truth, it's hard to explain this without making myself sound like a total psycho. But the reality is the way that I'm built is if I had completed this project and closed my laptop and never spoke of it again to anybody, and like maybe my 4 or 5 closest friends know that I'm working on it, but then like the world never heard, I would probably have been like 95% as satisfied as if like what I did end up doing, which is like announcing it and open sourcing it and getting it's brought me a lot of recognition, which I'm very happy to have. But I didn't do it for those reasons. I did it because I think I was born with the how hard could it be gene. It's kind of like what you said with the Mount Everest quote. Just I thought it was. I also, the ignorance played a huge role because I frequently thought I was just on the very cusp of hitting the problem that I thought would end the project, because all I wanted was to end the project. I didn't want this to work. I never believed. It's funny. I have lots of recordings of me working on this because I knew I might make a video, and there's a recording of me the moment that the project succeeded, that the frame of doom rendered, which took 12 days of running the type checker in like 177 terabytes of TypeScript types, and it's like a whole thing. But it's interesting that like it's kind of hard to pick out what, like, if I showed somebody the video, it's just like 4 minutes of me staring at the screen in silence, just like in disbelief. I mean, I could not believe that it worked, because I never believed that it would work ever until I couldn't deny it anymore because it was already done. And so it's one of those things where if I had known better what I was getting into, I would never have started. And
hindsight 2020.
Yeah, I mean, I think anybody, and I have friends who are like, I think are much better engineers than I am, that are much more experienced in some sense than I am with these kinds of systems level programming tasks. And many of them told me, like, why are you doing this? This is not going to work. How could this work? And I'd be like, yeah, I believe that it won't work as well. I'm right there with you. I also don't think that it's going to work. However, turns out it did. Yeah.
Yeah, it's funny. I'm thinking of Dan's question. So I'm looking at our programming thread on Reddit with this video. Like, first question is, what kind of daily occupation or regular financial backup support do you need to have the guts to invest 6 months into a joke?
It is a joke. Yeah. I mean, I think like What's funny about the way that this works out is I said the little personal tidbit about my marriage, but actually from like a career standpoint, what I learned in this project will, I mean, I am so much more capable now than I was before because I mean, I had never written C. Now I've written tons of C. I mean, for me anyway, I've written many, many, many tens of thousands of lines of C and worked with C and refactored C code bases and LLVM. I didn't really know what LLVM was, but now I know quite a lot about the internals of LLVM and how it all works. Also, WebAssembly, we didn't touch on it yet, but the way I actually physically achieved this goal was by building a WebAssembly runtime purely in TypeScript types, compiling Doom to WebAssembly, and then running that in my runtime. And so because I built a full WebAssembly runtime from scratch, like there's like 160 instructions that I implemented. And when I say from scratch, I have to remind you, like, there's no addition in the type system. So even addition was not available to me. I had to build addition off of abstractions of like adding and removing characters to binary strings that have like 32 ones or zeros stacked next to each other in a string. So I had to create all kinds of abstractions and constructs I didn't know. I mean, it's like down the list, I didn't know anything about two's complement binary numbers, and I built a garbage collector is in the runtime. I didn't know anything like how garbage collectors work and how that stuff works. So all of these things are so directly applicable. It's kind of funny. Before I announced the project, it kept happening that like basically every other day at work, something would happen that I would be able to contribute to my like what my team is building or what somebody else on the company is building. That was a skill that I picked up working on this project. I mean, it's so directly works out that way. And so in the end, I think I got a lot out of it from that perspective, if that makes any sense.
Oh no, makes perfect sense. One of the things that I don't know how often you listen to us, but one of the things I talk about is the kind of person that I am is very similar to you in that I like to know the internal details of how something works.
Yeah.
What's the little pieces that make it work? Because once you understand the smaller pieces, then that helps you understand the bigger picture and maybe even troubleshoot better.
Yep.
I started out my tech career back in the long time ago. Right 2 years after Doom came out, let's put it that way.
Okay.
And I can remember Doom being is Duke Nukem, is he the character in Doom, or is that a different game?
It's a different game, but actually the guy in Doom, his name is Doom Guy.
Doom Guy. Okay. So Duke, they all start with D, they run together. I've never been a big gamer myself. Anyway, I've always been the kind of person who likes to know the intricate details of how something works. And for my job, it was sort of necessary. The classic example I always give is as a Spanish speaker, I was somebody who learned language really easily, but there's two different ways you can learn. I think that you can learn a spoken language, more so than like a programming language where there's, the conversational people that, you take a conversational Spanish class and learn how to speak phrases and stuff. And you know how to say what you're saying, but you don't really understand the building blocks. Whereas the way I learned it was learning the building blocks, verbs, verb conjugation, which is sort of the crux of any language, right? Nouns and all the different verb tenses and that kind of stuff. So I understand it. So then once I have the building blocks, then I can piece things together and make a more complete whole. I'm waxing eloquent here, but I just started a new job this week in a new company, and going through the interview process, which is long in itself. One of the questions I got was basically I'm trying to remember how it was phrased, but how do you troubleshoot? How do you troubleshoot? How do you figure something out? What's your tools? And my answer was the best way to be able to do that is to know the system, right? If you know your system, you can spot when something's wrong as compared to trying to figure out, well, this must be this here, this must be there. If you know how it's supposed to work, then you can identify when something doesn't work. I can remember my first career out of college was in a bank. I worked in the operations side of a branch, and I did a lot of training and teller training and stuff in the day. And I can remember hearing a story. This was probably more before my time, but to me it makes perfect sense that the way they used to train tellers was you just give them cash and have them count cash, sit there and count for a long time. And then you
Yep.
start throwing in counterfeits. And because you know the original so well, then you can easily spot a counterfeit. Something's wrong.
Oh
All
wow.
let's get back to your point. You're talking about knowing WebAssembly and low level C stuff and garbage collection and binary and strings and stuff like that. That if you know all those little pieces, all the details, then you can easily, one, you can easily build something, and two, you can spot when something's going wrong.
Yeah.
Right. So to me, that's got to be an amazing
Well,
knowledge set to have
Uh,
to be able to know all that low level stuff and then piece it all together.
welcome
just to
back,
say,
Dan.
and I'm back.
Yeah, yeah.
Did you miss me?
Yes, we did.
Oh,
I'm
you were
happy
gone?
to
Oh, okay. Sorry. Anyway.
happy to report that apparently nobody was hurt in this barrage.
All right. Good deal.
Uh, yeah. So
Well, I
anyway,
mean, I
But I
think
was
I think
waxing
the
eloquent about knowing the details of the system based on what he learned from this project. So,
I think it's actually a perfect segue. Something that I hope people take away from this project is it's such a complex system that there's no way I could have kept it all in my head. And I knew that from the very first commit, from the very beginning. I knew if I ever really get far down, if I hope I find an early stopping point, but if I find a mid stopping, like I never thought I would get to the end. So that was like never on the table. But I thought even if I get to a midway stopping point, I will need to have an extremely extensive test suite. And so the way that I set it up is basically I run the same set of inputs against all these programs that test, because I told you there's like 116 instructions that I had to create in the WebAssembly runtime. So the system is set up to test the same inputs in that runtime 6 different ways. And so the I'll say them very fast. The first way is just, let's say the numbers are 1 and 2 and the operation we're doing is addition. So we run 1 plus 2 in JavaScript. So, okay, that's fine. We run 1 plus 2 as strings, as binary strings in JavaScript. That's fine. We do it again in TypeScript types purely. So we have a TypeScript routine that can do binary arithmetic, but it doesn't know anything about WebAssembly. It's just very low level. We do it again with decimal numbers in JavaScript, which actually under the hood converts to binary. That's 4. Number 5 is where it starts to get really interesting. I take those numbers 1 and 2, and I hand wrote a WebAssembly program that is 4 lines long and basically just does that one instruction. It takes those 2 parameters and does that one instruction in the simplest way possible. And then number 6 is where the rubber meets the road. I run that same set of inputs in my WebAssembly runtime, which itself is pretty simple, right? But it's taking that WebAssembly artifact that I also ran through the JavaScript WebAssembly runtime that ships with Node, and JavaScript is built into the JavaScript system. And this was the method by which I discovered all kinds of things that I had bad assumptions about. You say assumption, but it's like unknown unknowns, things I didn't know that I didn't understand. And, some of them got pretty far. You may have heard of like little endian and big endian. I had heard those words before, but I didn't really understand what they mean. And I accidentally, you have a 50-50 chance of implementing a system one way or the other if you're packing bytes into a memory object. And I accidentally implemented the whole system big endian without knowing it. And it was actually my test suite that uncovered this for me. Once it works out that if you you pack all the bytes in reverse and you read them all out in reverse, you can get away. WebAssembly is little endian by spec. It has to be little endian. But it was only once, it was very far along actually. It was only once I started working with memory instructions that operate on a portion of a byte. So I'm sorry, a portion of a word. So like just the first 4 bytes or the last 4 bytes. Then I started to get really weird results and I couldn't figure it out. And so I fixed it. And then later I was like, wait a second, is this what endian this is? And I Google it and it's like, oh, that's endian. So now I'll always know for the rest of my life.
So now if you Google it, do you know where the terms come from?
Yeah, it's like what's on what part is it? Does it go on
No,
the end?
but where the name big endian and little endian? Do you know where the origin of the name?
No, it's I thought it was just like end, like what's the significant bit?
So it's from Gulliver's Travels.
Oh,
When he visits the land of Lilliput, there are actually 2 countries there, and they have a war. And the catalyst for the war, speaking of wars, the catalyst for their war is when you have a soft-boiled egg, which side do you break the egg on? The big endian part of the egg or the little endian part of the egg. And that's
That's the source of their war.
that's the source of the war. And Gulliver obviously brings about peace and whatnot, but that's where the terms big endian and little endian
I love
came
it.
from.
You guys really
So
got my number. I love this kind of trivia stuff, so that's really awesome. Thank you for
so
sharing.
yeah, I'm Mr. Trivia. So
That's cool.
especially as related to history and programming stuff. Um, so I probably have missed it. You were talking about the fact that you implemented WebAssembly in the type system. So you
Yes.
effectively did not run Doom as Doom. You compiled Doom into WebAssembly and then ran the WebAssembly in
Right.
your type system runtime.
Yes. It was the first thing I tried. Actually, a friend of mine said, "Hey, who's very smart in these things?" He said, "You could probably do a Clang compiler target." And I was like, "Okay, I don't know what Clang is. I don't know what it compiles, and I don't know what a target is." But I started looking into that, and eventually, actually, it's what the funny thing is later I learned quite deeply what Clang is, and I worked a lot with Clang and different C compilation tools. But yeah, in the end, I tried WebAssembly and it never stopped working. So some people ask me like, what was your process for selecting WebAssembly? And it's like, it was the first thing I tried. I had never worked with WebAssembly before. I had no context or exposure to it whatsoever. This was the beginning.
Yeah, to
So
me, a clang is
basically,
always just a loud sound.
yeah. Well, yeah, it's a CLang compilation target.
Mhm.
Basically, it's
Yeah,
the output of LLVM or something, right?
yeah. It's a C compiler based on LLVM. It's part of the LLVM project, and yeah, it's very closely tied to that. Mhm.
So essentially, anything that can be compiled down to WebAssembly can actually be run theoretically, at least on your system.
Yep.
Super cool.
Yeah, I mean, it's funny. Like, I showed this to a few people before it was public, and there were about two people who had the reaction that, like, Dimitri, you're like vastly underselling what this is by talking about like focusing on Doom. You're ignoring the fact that you built a full web. Like, I can run Pong, I can run Tetris, I can run Pokemon, I can run anything. Not just games, but you can do any kind of arbitrary WebAssembly uh, computations with your system. And yeah, that might be true, but Doom makes a better headline.
Now, again, I apologize if this is something that you spoke about while I was otherwise engaged.
No problem.
Um, I understand that you actually had to modify the TypeScript compiler a little bit.
Yeah. So it was always very important to me. Like, so I'm a TypeScript nerd. I mean, I'd love not to be some days. I actually prefer Rust quite a lot, which some people find surprising. TypeScript is definitely not my like favorite language to write in. It's just the thing that I've written the most in and have the most familiarity with. But uh, in the end, I tried pretty hard to create something that you know uh, doesn't know anything about Doom and doesn't know anything really about TypeScript internals. And there are limits in the TypeScript type system that try to keep you from doing things like this. So there are like we talked about recursion. Okay, so TypeScript has a recursion limit. It's arbitrary. It's completely arbitrary. It's 100 recursions. If you make a type that recurses 100 times, TypeScript will stop and report an error. And that's just a thing that they built into TypeScript to prevent runaway, complexity, that you like accidentally do some kind of matrix multiplication of, wide types, and you get this like really crazy thing that takes so many, could take years to compute or whatever. You're like, it's just a safety check. It's a safety guard. Well, when I was developing this, I really needed to remove those safety rails because I needed to experiment with things that, I would later be able to break up into smaller pieces. I knew, but like when you're in the weeds, kind of trying to shoot around ideas about how to work on something, it's kind of nice sometimes to like let it be dangerous. And so
Mhm.
I modified, I patched. It's just like 10 lines of patches. It's not anything major, but there are these like you'd think like, okay, if the recursion limit is 100, does that mean there's a place in the code base that says like, recursions, number of recursions equals 100? And yeah, there is. So I just went to those places. I found those limits whenever I hit them, and I just changed them to like infinity. So
So,
that
for
I would,
example, probably also the number of types that can exist in the system
Right.
As a
Yep.
guardrail you had to
Yeah,
remove.
there's a type instantiation limit. There's a couple limits, and so these limits are kind of core to the um, TypeScript system, but they're totally arbitrary. And it actually does work without, like, the final thing that I created will render the frame of doom with vanilla TypeScript with no limits removed. But it was just very useful while I was working to be able to kind of like soft remove those
Mm.
limits. So,
So how long does it actually take to render one frame of Doom on your computer?
yeah, so it took 12 and a half days to get to render the first frame. And it was very important to me. Actually, I did a little squirrely business inside of the Doom code to make sure that the first frame is inside of a game level. Because the real first frame of Doom is actually just a static asset. There's like an image that ships with the file, that ships with the. I don't want to. We can get into Doom, like how Doom works internally if you'd like, but anyway, it's not actually that hard. Like it's just a picture that was put into the code base. But I don't want to do that. I want to boot the whole game. I want to boot the enemy system. I want to boot the game map rendering. It does like some kind of it's not ray tracing. What is it called? Ray casting. It does ray
Yes.
casting to kind of like figure out all the pixels of all the obstructions and all the geometry of the level. And there's like a system for your weapon and your health
As
and
an
your status.
aside, as an
Yeah.
aside, I need to mention that way back when in the day, I in the 90s, I actually worked at a gaming company, and I
Hmm.
literally implemented the Doom ray casting algorithm for the
Cool.
game that we developed. It
Oh, that's
was kind
awesome.
of like a multi-user Doom game. So I
I love that.
basically found pseudocode description of the algorithm. I figured it out. I implemented it in C. It was too slow, so I actually then compiled some of it into assembly language and hand optimized the assembly language that came out. So this was
Awesome.
obviously from my pre JavaScript days. So I'm kind of familiar with some of the stuff you're talking about, even though it it was a
That's
long
cool.
time ago. Um, so you picked a random frame inside a
The first
spot
frame.
inside
Yeah,
of
yeah.
the level, and then just rendered the first frame.
Right,
And
yeah, you can actually
and
change the game asset to force you into a level and immediately, so that's what
and
I
if
did,
it
yeah.
ran for 12 days, how did you know that it wasn't just stuck? I mean,
So
you were
funny story,
waiting for.
the run that succeeded was about the 18th or 20th run. I stopped counting after 11. Um, so I mean, it took almost a whole year to get to the point of, like, being able to even try to run the because the game is very large, right? It's like kilobytes of or actually megabytes rather of JavaScript. I'm sorry, of TypeScript types in one file. It's not like these systems are not made to handle megabytes of a single type being megabytes long. And so it took a long time to get to that point. I mean, when you build a system this way, you kind of can't run it until you've implemented all of the instructions, right? You like,
Hmm.
even if there's one, if you have 115 out of 116 instructions, like you will. What happens when you get to that instruction you haven't implemented yet is the system will crash. And so it took a long time to get to that point. But once I got to that point, it did infinite loop multiple times. I kept track of the runs and I was monitoring uh, their progress, like how many instructions they had gotten along through, and I implemented a system that would kind of dump what it was working on to disk temporarily so that I could like take a peek at what it was working on and see like how it was going. So it was a long process of getting to that, and I didn't really think, speaking of family stuff, it's funny how life happens. But actually, the final successful run was spun off on the night of Halloween, 2024, and I was running out the door, and I thought, I'll start another run because the previous one had failed earlier that day, and we were going to go trick or treating with my kids around my neighborhood. I thought, I'll just go push play. I'll come back to it. It's probably going to feel like I had long given up on it, the idea that it would just work by that point. And of course, that was the run that eventually succeeded 12 days later.
What can you describe your reaction when you got
Sure.
the
Yeah.
result?
Yeah. So I was saying, well, you're gone, but it's fun to talk about. I genuinely, in my heart of hearts, never believed this would be possible. I never, at any moment believed it until the very last millisecond when I couldn't deny it anymore. I mean, I was recording the screen and I recorded myself working on this throughout the project, and that was part of what was in the video. And there's more that I'm planning to release on this, but it's funny to watch back the video because it would have been nice if I had some kind of like big reaction, but it's just I was just stunned. I was just like immobilized, and it's like 4 minutes of
Shock,
silence.
right?
Yeah, it's just like like total disbelief and shock. And actually, you can see my eyes kind of darting around the screen, trying to find a place where like it didn't render a column in the level or something, some geometry. Uh, I just never I never believed it would be possible. I just never believed it until, well, I couldn't deny it anymore and it was done. So yeah, it's funny. Like, I don't know. I'm gonna, like I said, make a video about the why of this project. Like, why did I get trying to do this? And I have to find a way to like make it more palatable to show that reaction, because my reaction is basically just me just being like, just breathing heavy.
And then what did you do the next day?
um, I mean, I think I did what I would have done if I had been on the other side of this. So like one of the things I told to my wife is like, listen, because she would ask me like, like explain to me why this. She had never heard of Doom and stuff, so she doesn't know the history of people trying to run
Is
things
she
in
in tech,
Doom.
by the way?
No, she's not. She's not an engineer at all. So I would try to explain this, and I would say, okay, look, here's what it boils down to. If I was on the other side of this and somebody released this project, my eyes would glaze over. I would have to take the rest of the day off work. My eyes would glaze over. I would walk outside and stare at the sun and probably go blind. Like I would question everything about the universe. If this, like, it would really rock my world if this is possible. It just can't be possible. So like all I'm trying to do is show why it can't be possible, which means I could be done at any moment. I could be done today. I could be done tomorrow. Not sure, but I knew that if I was on the other side of this, I would just be like totally shaken. And despite that, I was in the driver's seat all along because I had this attitude of this couldn't possibly work. Yeah, that ended up happening. I didn't stare into the sun and go blind, but all the rest of it did. That I just kind of walked around, like fuzzy, like my body felt fuzzy for hours afterwards. I was just could not believe that it was like finally in front of me. I spent a long time believing it wouldn't be possible. Funny, it's
By the
such a
way,
stupid thing, but here we are.
yeah,
That's
well, the things in life.
mhm.
By the way, have you actually tried to run it on the new Go TypeScript compiler?
No, and I will never. So one of the things that is interesting, I also promised my wife I would never open the project up again, but actually I don't need to do that because it sounds funny to say, but I have like absolutely no interest in continuing this. Like I didn't have interest in doing it in the first place. I just got kind of nerd sniped into it, so to
Oh,
speak.
it's just that instead of 12 days, it should take a day and a half.
Yeah. And some people said like, "Oh, but like what about the second frame?" That was one of the common complaints on the announcement video. It's like, "But you didn't show any gameplay." And it's like, "Look, if I had rendered 100 frames, someone could say, 'What about the 101st frame?'" Like on a mathematical level, it is literally equally as interesting to say that I rendered 1 frame as I did to render 100, like or 1,000 or whatever the first level. Like I don't care about that part. There was the whole purpose of this project was trying to kind of like trick the TypeScript type system into doing this like very difficult task. And I
Yeah,
achieved
the
that.
point was never to actually play Doom at a frame rate of
Right.
one every 12 days.
Yeah. I say in the video, like, I didn't do this because I have no better way to play Doom. You know, there's lots of ways I could have played Doom if that was my goal. This was like a kind of mathematical pursuit, academic pursuit.
Yeah, it'll be interesting. I'm sure somebody will pick up the gauntlet or the mantle or something and probably
and I,
try to
and
get it run
and
to
it's
run.
open source. So if somebody listening is one of those people that would like to kind of, I don't know what the next level of this would even be, because to me, like, Doom is kind of like the finish line. Some people have asked me like, why did you go from nothing like this ever having been done before all the way to Doom with no stops in between? And it comes back to this recurring thing. It's just because I thought it wouldn't be possible. So if that's your mindset, there's no reason to play around with like Pong or Tetris or Pokemon building up to it. Like just go straight to Doom, to the hardest thing, and show why that can't be done, and then
And
that's it.
also the fact that you implemented WebAssembly
Right.
is the fact that you could run anything on it that, like we said, that can compile to WebAssembly. So Doom is just one example. It could be anything else.
Yeah, and in fact, I did actually, maybe I'm fibbing a little bit. I did actually implement one other program first, and it was Conway's Game of Life.
Mm.
So, Conway's Game of Life is this thing called a cellular automata for anybody listening, and it's just it's kind of like imagine a piece of grid paper, and you make a game out of like rules about which, grids are filled in on the paper. And I wrote that in C, so that was the first C program I had ever written, and that completed in January 2023. So from January all the way until November was how long it took. Like, it was a pretty full functioning system at that point for the instructions that Conway's needed. And again, I wrote it in C, not in straight WebAssembly. So there's actually quite a lot of instructions. There's like, let's say 80 instructions or something like that Conway's needed. But it took a lot more to get Doom running than just that. There's
Well,
quite a
yeah.
lot.
The
Yeah.
last 20, the thing about software projects, well, I guess projects in general, is that 80-20 rule. The
Hmm.
last 20% takes 80% of the time and effort,
Yep.
basically.
Definitely was the case here.
Mm. Oh, super cool. So, and then you basically just put it aside and continued with your life.
Yeah, I haven't touched it, not one bit, since the day of the announcement. Anyway, I had to like rework the README. It's funny, I committed a lot, so if you read the commit history, it looks like I'm totally out of my mind, which maybe you could argue that I was while I was working on it. Um, but it's a lot of like capital letters and exclamation points and a decent amount of swearing. And actually, I have a sort of self-deprecation. I find self-deprecation very motivating for whatever reason, and so like in the code base, it's like there's a lot of like, "You dummy, what are you doing?" type of comments and things. But whatever the case may be, it was a solo project, and you don't have to follow all the rules you do at a project at work. But yeah,
Now,
I haven't touched it.
when it came out, you spoke with some TypeScript or web
Yeah,
personalities. I recall from your videos, in particular, your conversation with Anders.
yeah. So
Uh, can you tell us a little bit about that?
yeah, that was a really awesome moment. So because of the channel and work that we've done on Michigan TypeScript prior, I had an opportunity to do some videos there. I think probably 5 members of the team have been on the Michigan TypeScript channel for various, it's always very nerdy things about interviews about TypeScript or trying to solve particular type challenges and stuff like that. And so I had been asking them about, hey, it'd be really cool, because when I showed it to people privately, people had said, "Hey, I wonder what Anders, the creator of TypeScript, thinks about this." And I would say, "You're not going to be the only person wondering that. I'm going to try." And so I tried and tried and tried, and eventually they said, all right, we'll throw you a bone." And Anders, I'm very gracious that he took the time to meet with me, and I had a chance to show him the project and kind of give him a demo of it. Yeah.
Yeah, I'm literally an Anders fanboy.
Most of us are, yeah.
Well, in my case, it goes even further back because he's not only the guy that created the TypeScript, he's also the guy that created C Sharp.
And Turbo
But
Pascal.
yeah, and that's the
I,
thing.
Oh
actually,
God, that brings back some memories.
I can't believe that I forgot to say this to him when I met with him, but I was just so nervous and starstruck. But Turbo Pascal is actually the language that the original Tetris was first implemented in.
Really?
Turbo Pascal is the programming language that made me a programmer. I literally ran Turbo Pascal. For our listeners who don't know, Pascal is a programming language originally created by Nicholas Wirth for teaching computers. It's a typed programming language. It based on the Algol family of programming languages. But my point was that up to that point, I was writing ugly basic stuff, and then this thing comes along with an integrated IDE and a super fast type safe and a compiler for type safe programming language. So I literally almost overnight went from being a hobbyist to an actual programmer. And
Yeah.
it's
Wow.
really thanks to Anders and Turbo Pascal.
You know what's
It
funny
was an
about that is
amazing
that
system.
when I was in college, so I graduated college in 91, and I took a basic class, I want to say 89, 90, I think. I remember programming in basic, and then I took Turbo Pascal my senior year, barely passed by the skin of my teeth. I mean, I barely passed. And I can remember, and this makes me laugh today. I can remember having problems getting my head around things like arrays, and we had to come up with this card game for a final project, and I barely did the minimum, didn't even did that. And there's this one girl in the class who aced it, and she had gambling, and you could place bets on things. It just totally blew away. And then I got into PHP later and lived in arrays for a long time, but oh man, Turbo Pascal brings back
So
either
he did Turbo
memories and
Pascal.
nightmares at the same time.
Yeah, so he did Turbo Pascal. He did Delphi, the Delphi programming language. Then he created C Sharp, and
Hmm,
now TypeScript. He's one of my dev heroes.
interesting. All
It
right.
was a big moment. Yeah.
So we're sort of running out of time here. So before we wrap up and move to picks, is there anything else we didn't cover that you wanted to cover, Dimitri?
I think we got it. I just hope people that hear about this project understand a few basic things that made this successful. Contrary to most ways that we like to think about, building complex systems, if I had sat down to make a plan, this would never have been possible. I just put one foot in front of the other every day, and I kept notes about what I needed to do next as I went. But I never at any point had a big grand plan about how to do this. And it was probably not even possible in my case because I would never have been able to know what things I would hit.
So in
But I
other
didn't
words, it
let
was
that.
more of an agile methodology than waterfall.
I don't know. Those are both trigger words for me, so I can't comment. But but I think that sometimes people struggle with motivation to try, and I think that trying is all you need to do in a lot of cases. I never got down on myself about failing because the definition of failure was built into the thesis. I was trying to fail. I was trying to fail. I was trying to make it not work, and just trying to find why it can't work. And I think that I learned from this, and I hope people can get from it that I said earlier in the call that 95%, I would have been 95% as happy if I never told anyone about it. The 5% is I really do get a lot of enjoyment out of people, have reached out to me privately and online and stuff saying like, I, because of this project, was inspired to pick up some old project that I had given up on, and I'm going to give it another shot. And I hope people take that away, and that's like really the main message I want to leave people's minds having. Yeah.
One more important thing that you said, that I wanted to call out because I think it was very insightful, is about taking big problems and breaking them down into smaller problems
Yep.
and doing this project process recursively.
Yep.
And I think this ability of breaking down difficult problems into smaller, more manageable problems, and then composing the solutions back in order to solve the original big problem is what makes an engineer, really.
Yeah.
This ability to me is at the core of what we do. And it was really insightful for you to bring that up, and really important, I think.
I couldn't agree more. Yeah. I love it.
Alrighty. So with that, we will move on to picks. Picks are part of the show where we get to talk about anything we want to talk about, whether it's tech or non-tech related. So Dan, I'll have you go first today. What do you have for us besides sirens going off in the background?
Well, my pick will actually be in this vein. So, without going into, the details of what this war is about and whatnot, we are living in a situation where in Israel are having large missiles being fired at us, and by large I mean something like 1,000 pounds warhead of full of explosives. As you can imagine, that can cause a lot of damage. And what makes a huge difference is the fact that we've got the system in place for intercepting and shooting down missiles. It's not a foolproof system. Such systems cannot be foolproof by definition, but it's very effective. It's something like it has an effectivity of something like 90%, which is like huge in these types of scenario. If you think about the fact that around 30 people have been killed in Israel since this thing started. Think of, they make it 10 times bigger or even more. That would be, yeah, devastating. The reason that I'm picking this is that I'm proud to say that in my background, I was actually involved with the creation of these systems way back when I actually served in the IDF. I served for several years as an officer in the Israeli Air Force, and where I primarily served was at the Air Force Test Range, where I was intimately involved with the development of the Arrow system, which is that part of the multi-layered missile defense system that actually is intended to intercept and destroy the ballistic missiles.
Is
Most
that
people
Iron
are
Dome?
no, so most people are familiar with Iron Dome because it got a lot of press and it's got a cool name. But Iron Dome, like I said, it's a multi-layered system. Iron Dome is actually for the lowest layer, so it's
Hmm.
against mostly against rockets. So when Hamas was firing rockets at Israeli cities, those were intercepted by the Iron Dome. But then you've got additional layers. You've got David Sling, and finally you've got the arrow, and the arrow is the one that's supposed to intercept ballistic missiles. Ballistic missiles, in case you don't know, literally fly out into outer space before falling back down to earth. And the arrow is actually able to intercept those missiles in space. It's pretty nuts when you think about it. Right now, Israel is using Arrow 3. I'm old, so I was actually involved in the development of Arrow 1. But things grow, evolve from one to the next. So I'm proud to say that I had my small part in the development of that system. Hopefully, this war will end soon, and we won't need those anymore, and at least in the immediate future. Until that do, I'm happy to have them and to have them protecting us. And I guess that. Oh, yeah. My personal part was relatively small. That would be one pick. The other is not a pick; it's more of an announcement. In the last episode that recorded, I told that there's a conference in Israel. Actually, it's a dual conference. It's React Next and Node TLV. They are kind of back-to-back conferences. React Next is Israel's largest front-end conference, and Node TLV is obviously about Node. Josh was actually supposed to come and keynote the No TLV conference. Obviously, he can't do this at this time. I was actually supposed to keynote React Next. For obvious reasons, these conferences have been postponed, so now they've been rescheduled from the end of this month to mid-December. Hopefully, by that time, all this stuff will be behind us and we can have conferences like normal human beings. And that would be my announcements and picks for today, I guess.
All righty. I will go next and go to what I prefer to think of as the high point of our podcast, which is the dad jokes of the week. The other day, I went into the library and I told the librarian, "Hey, I'm looking for a book about turtles." And he said, "Hardback?" And I said, "Yes, with small heads." Right.
Okay.
Question. So humans can catch diseases from monkeys and bats, but why not anteaters? Because they're filled with antibodies, right?
Uh,
Okay.
And then,
yeah.
and then one day, I made a call and I said, "Hey, is this the gambling addicts hotline?" And the operator said, "Yeah, how can I help you?" I said, "The dealer had a 10 against my 16. Should I hit or stand?" Right?
Hmm.
I was asking for help on gambling. Anyway,
Yeah, I get it. Um,
Dimitri
yeah.
looked a little confused, so I
I don't
wasn't
think
sure.
I think I still don't get it, but
Well,
maybe that's part of the
gambling addicts
process.
hotline, you call to get help to avoid gambling, but I was calling for help on a
I
hand
can
whether I
tell a
should hit.
funny story about the fact that, and this is a true story. So, the company that I used to work, we would go out to eat lunch at some restaurant, and we would go there pretty regularly. So we got into kind of friendly terms with the owner, and he would come and sit with us when we arrived. And he liked gambling. He would literally, when he could, go out to some casino to play. And he told us about how stupid some of the other gamblers are, that he was at the roulette table and it came up black like 4 times in a row, and one of the other people put it on black. They bet on black again. He said, "What's the chance of having coming black 5 times in a row?" And we didn't want to correct him because we didn't want to get poisoned the next time we came to eat or something. But yeah.
All right,
Anyway.
Dimitri, your turn.
I'm going to give it up to TS Morph. For those of you who haven't seen it, it's a project that allows you to do conversions on the kind of AST. You can describe changes and refactors to a project based on its AST, and it's a pretty cool project. And I don't know, I like it. It's the first thing that came to mind, so I thought it'd be authentic if I just tell you what is on my mind that I like. Let's see. Is that the pick? Wait, is there 2 things I'm supposed to pick?
You can pick
No.
whatever you want. I
Oh, okay.
expected you to pick SquiggleConf, by the way.
Oh yeah. Okay. So, hey. Okay. Great. You read my mind. Also, so we've talked about Josh Goldberg.
Well, we read your shirt too.
Okay. Yeah. So before the call, I was saying at SquiggleConf. So I run a conference with Josh Goldberg. We're co-founders of SquiggleConf, and the name is such because it's a dev tools conference. So
Ooh.
there's lots of people that are making dev tooling, and that's their kind of bread and butter, even internally at a company, but externally, library authors and stuff like that. And SquiggleConf is a place for those people to get together and ruminate in the things that they learned building these tools.
Oh,
It's a cross-language conference, so it's not a TypeScript conference only. We have representation from Rust. Last year we had Zig. This year we're having Gleam as well, up-and-coming language. C++, C# is also represented. Go, there's two talks focusing on Go this year. So it's a really cool opportunity to get experience and exposure to what other communities and other languages are doing. And yeah, we're very passionate about it, of course. You have to be to run a conference, but I didn't even realize that I didn't know that we were even being video recorded today. Last year at the conference, somebody spilled some coffee on a bunch of SquiggleConf 2024 shirts, and so we couldn't sell them. And so now I have like 5 SquiggleConf shirts, which means that when I reach into my drawer to pull out a shirt in the morning, there's a like abnormally high chance that I'll pull out a SquiggleConf shirt, which is they're very comfortable, so it works out.
A little bird just mentioned, a little bird called Josh, just mentioned on our chat that you have a great dad joke about Richard Nixon
I don't have a great dad joke about Richard Nixon.
working at a restaurant.
I don't know.
Uh-oh.
Yeah,
Uh-oh.
I don't know. I'm sorry. I'm sorry to disappoint you, Josh. I may know and have forgotten. I'm not very funny. Maybe I can own that. Oh well.
By the
But
way,
SquiggleConf-
also, I highly recommend people watch the videos that you created. Where can people find them?
Oh, well, sorry. One last thing I forgot to mention. So SquiggleConf this year is in Boston on September 17th and 18th. It's a really cool venue. It's in the New England Aquarium, and there's a big IMAX screen, so it's like super comfortable. And it's a 2-day conference this year. We just this week announced all of the speakers and all of their talk topics. So you can go read the list. Just go to squiggleconf.com, SQUIGGLECONF, and you'll find all the information there. So please take a look. Also, in kind of parallel to that, yes, I run the kind of video aspect of Michigan TypeScript, but there's lots of other people involved with Michigan TypeScript. Is this other project from my home state here in Michigan? We have a meetup that meets once a month. Actually, we're meeting in 2 weeks from yesterday, and we're going to be definitely represented. We have a few people coming out to SquiggleConf as well from Michigan, so it's a good time. I enjoy this kind of stuff. Labors of love, you know.
So I have, as a homage to Josh, he basically wrote out the joke in the
Okay,
chat.
all right, let's hear it.
So turns out that Richard Nixon worked at a restaurant. Apparently, he mostly worked front of house. They offered him a space in the back of the house, like working food prep and culinary work, but he declined, saying, "I'm not a cook."
That's a joke.
That was a long
Yeah,
road
that-
to hoe for that one, but we'll give it to
Yeah.
you.
Okay.
We'll give it.
It's not
Thank you,
me,
Josh.
it's Josh.
Yeah,
you
right.
know.
Pass the buck.
Right.
All right. So with that awesome dad joke, we will end this episode of JavaScript Jabber. Thank you, Dimitri, for coming on. Thank you, Dan, for joining us, sirens and all. And we will talk at you next time on JavaScript Jabber.
Thank you for having me, guys.
Thank you really for coming on. Amazing project.